to discuss classification. First of all, let us discuss what is a force. A force is any cause that causes some effect. It causes some effect or it causes some change in the state of rest or of uniform motion of a body. In the force is by Newton's second law of motion, force is simply defined as mass of the body multiplied by acceleration of body, that we are going to discuss further, and the unit of force is Newton, that is kg meter per second square. You can have dimensions as m l t raised to minus 2. So let us now discuss classification of forces. Forces could be coplanar and non-coplanar. In coplanar forces, you have first of all collinear forces, then you have concurrent, coplanar. Now concurrent could be either non-coplanar or coplanar, so we need to specify whether it is concurrent coplanar or concurrent non-coplanar. Then you can have parallel forces, which ultimately leads to moment, and then you can have non-concurrent, non-coplanar forces. So first of all, let us discuss collinear forces. The concept is very much simpler. The collinear forces are the forces acting along the same line, that is F1, F2 and F3. They are acting along the same line. You can have examples of a similar example, like if a system of luggage is moving on a conveyor belt, although the conveyor belt is not undergoing any acceleration, but by analogy you can say that all of them are having motion under the same sense. The forces are the inertial forces experienced by the luggage in the conveyor belt. If they are having any kind of acceleration, the inertial forces on each luggage would be collinear. Then you can have the concept of concurrent coplanar forces, where in concurrent coplanar forces all the forces are acting along or either acting on a same point, or either you can say originating from a same point, and they all are acting on a same plane also. In this system you are having concurrent coplanar. In another system, if I am having, suppose this is x, y and z axis. Now suppose two forces are in the xy plane, two forces are in the yz plane, and two forces are in the xz plane. So now you can say that individually these two forces and these two forces are coplanar concurrent forces. But if you consider all the six forces together, then you can say that they are concurrent but not coplanar. So they are concurrent non-coplanar forces. Let us discuss one example of concurrent coplanar forces. At a point, suppose I am having force in y direction is 5 kN, force in x direction is 6 kN, force in any particular direction, say theta is equals to 45 degree, is 7 kN. At theta equals to 120 degree, I am having a force of 8 kN. And at theta equals to, suppose this is 230 degree, from here it is theta equals to 9 kN. Then the resultant of all the forces can be arrived at by the following vector addition, as along x-axis if I represent sigma fx equals to 0. So total sigma fx would be equals to 6 plus 7 cos 45 plus, you can say 8 cos 120, or you can directly put here minus sign and just write 8 cos 60 degree. Then you can have minus 9 cos 50 degree. The summation of all these forces will lead you a single resultant along positive x direction or negative x direction, whatsoever the answer may be. And sigma Fy would be equals to 5 kilonewton plus 7 sin 45 plus 8 sin 60 plus 9 sin 50, or it would be minus 9 sin 50 because the force is actually downward, or you can simply write plus 9 sin 230. So the meaning would be same. So now you have this force, suppose its magnitude is A, and this force, suppose its magnitude is B. So you are having force of magnitude A along x direction and force of magnitude B along y direction. The directions may be upward or downward, that is upward, downward, or left and right, as whatever be the answer over here. So this could, the resultant you can represent as, the resultant R is equals to under root A square plus B square plus 2AB cos theta, as we have derived earlier, where theta is the angle between the two forces, that would be 90 degree.